Hello class, this is a video recording of chapter 14 of the Business Mathematics text, and the chapter is titled Annuities and Sinking Funds. Some of the learning outcomes of chapter 14: find the value of an ordinary annuity using the simple interest formula. Find the future value of an ordinary annuity with periodic payments using a $1 ordinary annuity future value table. An annuity, you're also going to find the value of an annuity due with periodic payments using the simple interest formula. Find the future value of an ordinary annuity using the simple interest formula. An ordinary annuity with periodic payments using the $1. Is this the same thing as this here? Yes, it is. It's the same exact thing. Okay. And we're going to find the future value of a retirement plan annuity as well in this chapter. An ordinary annuity or an annuity due using a formula or calculator application. Some key terms: an annuity payment. Whenever you see the word annu in finance, this is like a prefix to annual, like per year. So an annuity payment is a payment made to an investment fund each period at a fixed interest rate. A sinking fund payment is a payment made to an investment fund each period at a fixed interest rate to yield a predetermined future value. And an annuity certain is an annuity paid over a guaranteed number of periods. Contingent annuity is an annuity paid over an uncertain number of periods. An ordinary annuity is an annuity for which payments are made at the end of each period. Annuity due is an annuity for which payments are made at the beginning of each period. Find the future value of an ordinary annuity using the simple interest formula method. Calculate the value of an account subject to periodic investments or payments such as retirement funds, college education, vacation, company's future investment and capital expenses. Using the simple interest formula method. Step 1. Find the end of period principal. So the end of period principal is the annuity payment. And now, whenever you see an annuity payment, usually this can go both ways. If you have an investment, for example, and it is an annuity, the investment can be paid to you per annum or every year. Or it can work the other way around. If you have an annuity due, you pay per annum out. So it can actually work both ways. It doesn't necessarily imply money in, money out. Just annuity is just a term indicative of per year. So for step 2, for each remaining period in turn, end of period principal equals previous end of period principal times 1 plus period interest rate plus annuity payment. And in many of the chapters reflecting back, we always see that whenever you have interest rate in parentheses, there's always usually a 1 plus. And the reason being is because that's how you increase by a certain percentage. So of course, if you're increasing by 5%, you will multiply by 1.05, 0.05 rather, which is the interest rate of 5%, and then 1 because you're multiplying your principal times itself, which is why we use 1, and then 0.05, which is the interest rate increase. So we're getting our principal back plus the interest rate increase, and then plus the annuity payment for this particular formula. Using the simple interest formula method. Step 3, identify the last end of period principal as the future value. The future value equals last end of period principal. So here's an example to clarify this, because as I prepped for this PowerPoint presentation, the textbook itself, the whole chapter, does such an excellent job of explaining in depth what these concepts means. The PowerPoint presentation just kind of jumps right into the topic, but make sure that if you're looking at chapter 14 in this method without reading the book, that when you're done watching this video recording, you definitely read chapter 14, because there's no way that you're gonna get that you're going to have an understanding of annuities and future value of ordinary annuities by simply watching the video. It is important, and all of the chapters are important, and of course I encourage all of you to read all of the chapters, but this is one of the chapters that I feel you really need to dive into. So here's the example. What is the future value of an annuity, of an annual ordinary annuity of $1,000 for 3 years at 4% annual interest rate? So a lot of times when you see these problems, you're gonna pick out some information from these. So we know that we're looking at an annuity. It's an ordinary annuity. We're looking for the future value. We have principal, $1,000. We have the period, which is 3 years, or if you're using the TI financial calculator, this is N, 3 years, or T, if you're looking at it in mathematical formulas, but this is the time period, at 4%, which is the rate. So now that we've picked out the important parts of the question, the first end of year is 1,000, right? So no interest earned year 1. End of year 2, you have 1,000 plus 1,000 times the rate, and now you have $2,040. End of year 3, we have $1,000 plus end of year for year 2, which was $2,040 times the 4% equals $3,121.60. So the future value is $3,121.60. This actually makes a little bit more sense when you know a little bit about how bonds work, because you definitely know how much money you're anticipating if you put money away for a year. Not so much if you're looking at like at the consumer banking level for bank accounts or anything like that. This is for regular ordinary annuities that are definitely 4 years annual interest. It's not as complex as how when we saw previous chapters we're dealing with compounding or anything like that, or with compounding periods of like days and weeks and months and stuff. So here we have a chart. End of year 1 we have $1,000. End of year 2 we have 2,040, and then here's the increase, right? And then end of year 3 we have $3,121.60. Now, although this is a very happy scenario here, it is highly, highly, highly unlikely that you will find a bank account that will triple your money by the end of the 3rd year. I can nearly guarantee it, at least not in savings accounts. Here's an example, another example. Find the future value of an annual ordinary annuity. So now we know it's an annuity, an ordinary one. We're finding the future value of $1,500 for 4 years at 3% annual interest. Now, they didn't explain it, not much of an example, but if you work out the problem just like how the previous one, how we worked out the previous one here, you should get $6,270. Find the future value of an ordinary annuity with periodic payments using a $1 ordinary annuity future value table. Now, as I've said before in previous video lectures, if you do not refer to the $1 table on page 495, there's no way that you're gonna get this. So make sure that you're using your book and that you refer to page 495 so you can understand this section. Step 1. Select the periods row corresponding to the number of interest periods. Once you do that, you select the rate per period column corresponding to the period interest rate. Locate the value in the cell where the periods row intersects the rate per period column, so you're finding the intercept. Step 4, multiply the annuity payment by the table value from step 3. So here's an example. Use table 14-1 to find the future value of a semi-annual ordinary annuity of $6,000 for 5 years at 6% annual, compounded semi-annually. A mouthful, I know. But what is this telling us? We know that we're looking for the future value. It's a semi-annual ordinary annuity. Keyword semi-annual, $6,000 present value, right? For 5 years. This is the period, or the N if you have the finance calculator, at 6%. This is the rate, annual interest. And we know that it compounds semi-annually. Okay, so keywords. So here's how you work it out. We know that we have 5 years and 2 periods per year. So in total we have 10 periods. So then the first step is really trying to find out how many periods we're going to look at, because that's going to be key in the formula. Next, you have the 6% annual interest rate, which is given in the problem, divided over 2 periods per year, because we're looking at 5 years, and there's two, and I don't know why I did that. Okay. So now we know that it's 6% annual interest rate, 2 periods per year, which gives us 3% interest rate per period. So then we're dealing with semi-annuals, right? So semi-annual implies 6 months. So then every 6 months you're looking at a period of 3% in those in between those. So for the first 6 months, 3%, second 6 months, 3%, and that's where you get the total 6%. See table 14-1 for 10 periods at 3%, and then you'll find, if you refer to table 14-1, like I asked you to, 11.464. So the future value equals 6,000, which is given from the problem, times 11.464, which equals 68,784. The future value of this annuity is 68,784, although that seems a bit high. I'll have to work that one out, and I'll make edits if need be. Here's another example. Find the future value of a semi-annual ordinary annuity of 5,000 for 10 years at 4% annual interest rate, compounded semi-annually. And if you work that out, you get 121,485. Annuity due versus ordinary annuity. The difference between an annuity due and an ordinary annuity is whether you make the first payment immediately, which is called annuity due, or at the end of the first period, which is an ordinary annuity. Find the future value of an annuity due with periodic payments using the simple interest formula. So now we're looking at simple interest. Find the first end of period principal. The first end of period principal equals the annuity payment times 1 plus rate, like how we do in all the other problems. Step 2, for each remaining period in turn, find the next end of period principal. So then you got the previous end of period principal plus annuity payment times 1 plus the rate. Step 3, identify the last end of period principal as the future value. So here's an example. What's the future value of an annual annuity due of $1,000 for 3 years at 4% annual interest rate? So we're looking for future value. End of year 1, you have 1,000, which is given from the problem, 4% times 1.04 to increase 4%. So now we got $1,040. So you bring that over, $1,040 plus 1,000 given, right, which is the present value, times the rate. So then when you do that, you have 2,121.60. Then you bring this over here, and then you have 2,121.60 plus given times 1 plus the rate equals 3,246.46. The future value is $3,246.46. So here's another example. If you'd like to work this problem out, you can pause it. To find the future value of an annual annuity due of $5,000 for 3 years at 4%. Find the future value and the total interest earned. So now you want to be careful. If My Math Lab asks you for a question like this, you want to make sure that you provide both if it asks you for both. The future value is $15,824.32, and the total interest earned is $824.32. And as you're doing my math lab, hopefully you've been taking advantage of the videos and of the notes that are embedded in each one of the questions, and definitely always try to take advantage of the fact that my math lab for the homework assignments allows you to take them over and over and over again. That's really helpful in helping you and increase your grade. Find the future value of an annuity due with periodic payments using a $1 ordinary annuity table. Again, if you don't refer to page 495, you won't understand this section. So please make sure to follow along with page 495. Step 1, select the periods row corresponding to the number of interest periods. Step 2, select the rate per period column corresponding to the period interest rate. Step 3, locate the value in the cell where the periods row intersects the rate per period column, so where X and Y meet. Multiply the annuity payment by the table value from step 3. Then you multiply the annuity payment by the table value from step 3. Multiply the amount that is equivalent to an ordinary annuity by the sum of 1 and the period interest rate to adjust for extra interest that is earned on an annuity due. Future value equals annuity payment times table value, or in finance we use the term present value, PV. I don't know if we're using that terminology, but we'll just go with it. The textbook says table value or face value. Annuity payment times table value times 1 plus the rate. So as an example, numbers sometimes do a better job of explaining things than words do. Using table 4-1, find the future value of a quarterly annuity due. So remember, quarterly means a fourth, which means that if you're looking at a year, you're going to have 3 months, because there's 4 sets of 3 months in a year. Again, find the future value of a quarterly annuity due, so it's annuity due, not an ordinary annuity, of $2,800 for 4 years at 4% annual interest compounded quarterly. So now we have 4 years times 4 periods per year, which equals 16 periods. Okay, 4 years, 4 periods per year, because quarterly is a fourth, so there are 16 periods total. 4% annual interest rate divided by 4 periods per year is 1% per period. On table 14-1, the value for 16 periods at 1% is 17.258. And just so you know, if you do have the Texas Instrument financial analyst calculator, you would actually plug this in as like present value 2,800, period 16, you would put 16N, rate 14, and then compute future value, and then that would give you this answer. So then what this really is, it's just like it's a value that's kind of like behind the scenes for you to eventually get the end result in the computation. But the table does help, because the numbers are all accurate. So the future value equals 2,800, which is given, right? Present value, face value, current value, times this factor, which is obtained on table 14-1, times 1.01, which is itself times 1%, because it's 1% per period, and that gives us $48,805.62. So the future value of this annuity is $48,805.62. As an example, using table 14-1, find the future value of a quarterly annuity due. Again, we have quarterly, which means that we're looking at fourths of a year, of $1,800 for 3 years at 8% annual interest, compounded quarterly. So now 3 years, quarters, we're gonna multiply 3 times 4, which is 12. So we know that there's 12 periods. And when you work that out, you get $24,624.43. And if you're finding yourself doing these problems and you don't get this answer here, the $24,624.43, as I've said throughout the entire term, you can always email me, let me know what slide you're working on, or which problem it is that you're having, and I can work with you to see what it is that you're doing wrong to make sure that you don't have any trouble while you're doing my math lab, okay? There are many different types of retirement plans available, including retirement plans available through your employer, such as pensions, such as like for government jobs and what have you, teacher jobs also, 401k plans, 403b plans, 401k, 403b, these are actually just these are sponsored by your employer. Usually, your employer will put into these accounts one or the other, um, for like a certain percentage of your paycheck, and then usually you'll have the option of also contributing a little bit more, up to like 6, 7, or 8%, depends on the employer, and usually they'll match you. The matching part is the kicker, especially in our generation right now of workers, because the stock market is extremely volatile, and essentially there are financial firms that manage these accounts, the 401k plans and the 403b plans. 403bs are more common when you work for a nonprofit, or for a university. Sometimes in a university setting, they'll give you both. If you're like a tenured professor, or if you're like a teacher in the educational system, usually you might get a pension, which is paid for entirely by your employer and others. So one thing to keep in mind is that a lot of times I find that people mistaken Social Security as a retirement plan, and it's actually not meant to be that. And actually, when Social Security was designed, you can do a little bit of research into this. They always set the age, the retirement age, and the Social Security eligible age at a little higher of the average life expectancy. So it's actually something that you're paying into that statistically you may not ever get. So it's not meant to be like a retirement plan or anything like that, the Social Security plan. It's more like supplemental. So when you're looking at retirement plans specifically for planning for the future after you're done working, these are some of the main ones that we're looking into: pensions, 401k plans, 403b plans. And if you hear the word company sponsored, jump on that, because that's really what's gonna um, you know give you a real good boost in retirement planning. Retirement plans are available to you individually, such as a traditional individual retirement arrangement, IRA, or a Roth IRA, or individual retirement account, IRA. Regular contributions made to a defined contribution retirement plan, or either form of IRA, constitute an annuity. The future value of the annuity is determined using the same methods found earlier in this chapter. Payments made at the end of each period signify an ordinary annuity, while payments made at the beginning signify an annuity due. So as an example, Ethan, who's 20 years old, plans to contribute $5,000 each year to a Roth IRA. Using table 14-1, find the future value of this annuity due of $5,000 per year for 40 years at a 4% annual interest compounded annually. Now, one thing to keep in mind when you're looking at 401k, 403b, sometimes the the interest rate is not guaranteed. So it's something that you want to take a look at and make sure that if you do have like a company sponsored 401k plan, 403b plan, and you hear that being said, then usually you'll have a financial representative from that company help you with your stuff. You can ask them all the questions you have about your account, the direction it's going in, You know, whether your money's in risky stock or if it's in a conservative portfolio consisting of bonds and whatnot. So always make sure that you talk to your financial representatives because they're essentially getting paid also from the gains on your account. So here, going back to the problem, we have 40 years times 1 period per year equals 40 periods. So 4% annual interest rate divided by 1 period per year equals 4%. Using table 4-1, value for 40 periods at 4% equals we get the number, the multiplier, 95.026. So then the future value is 5,000 times 95.026 times 1.04 equals $494,135.20. So the future value of this annuity is $494,135.20. Now, if Ethan is 20 years old and he puts in this money into this account for 40 years, he's going to be 60. One thing to keep in mind is that we don't know what's going to happen in 40 years or in 10 years, in 20 years. Maybe the age where you can actually tap into this money will be pushed up a little higher. There are certain rules. If you withdraw the money that you have in this account before a certain age, you get penalized. Usually it's 10% that they have to withhold for taxes. Then there's also a penalty of 10%, and then on top of that, you have to add this to your income when you file for income tax. So then you get taxed on it. So it's kind of like a triple hit in a way because you know you don't really get this may be the ending balance of your account, but if you withdraw early, there's going to be penalties on it, significant ones also, which is why it's important that you make sure that if you can, you maximize your contributions if you can afford it, especially if your employer has a matching program, because then that way over time your employer puts in the same amount of money you put in and you'll see your money grow significantly regardless of what you know of this actual percentage. Okay, so then there's those two different types of gains. You can have the interest rate gains, or you can also have the gains from your employer, which isn't going to matter right away, but it will in the future because it adds up. Find the future value of an ordinary annuity or annuity due using a formula or calculator. Step 1, identify the period rate, R, as a decimal equivalent, number of periods, N, and amount of annuity payment, PMT, and substitute the values into the appropriate area. Now, let me take out my Texas Instrument BA2 Plus financial analyst calculator. So then, like I showed you in previous videos, there's 1, 2, 3, 4, 5 buttons across the middle of the calculator. N, which is for number of periods. Then you have I or Y, which is for the rate. So it's actually not R, it's I dash Y. That's the interest rate button. Then you have PV for present value, PMT for payment. So this is where this comes in handy, and then FV for future value. So those are the 5 main buttons that you're going to be using. So identify the period rate R as a decimal equivalent, number of periods N, and number of annuity payment PMT, and substitute the values into the appropriate formula. So here we have the future value of an ordinary annuity. It equals the payment, and then here we have in parentheses 1 plus the rate times N minus 1. So R is the rate, so 1 plus the rate time, and then the exponent is the number of periods minus 1 over the rate, and then you multiply that by payment. So if you're working in the order of operations, if you remember, please excuse my dear Aunt Sally from a long time ago, you do parentheses first, then exponents, then multiplication, then division, then addition, then subtraction, and in that order. The future value of an annuity due equals, and then in parentheses you have 1 plus rate times to the exponent number of periods minus 1 over a rate times 1 plus the rate times the payment, and then that's going to give you the annuity due. So here's an example. Find the future value of an annuity. Oh, gave you the answer right away. Well, anyways, find the future value of an ordinary annuity of $100 paid monthly at 5.25% for 10 years. So here we have the rate, which is 0.0525, and it's 0.0525 because if we have 5.25%, you have to move the decimal 2 spaces to the left, right? So then here we have a 0, and so it's not 0.525, it's it's 0.0525. Okay, so then it went from here 2 spaces to the left, divided by 12, and then this is going to give us the rate by period. So it's 0.004375 period rate per the interest rate in the period. So then we have the future value of the ordinary annuity equals $100, which is given in the problem. In parentheses we have 1.004375, which is the rate per period, and then here we have 120. And the reason why we have 120 is because it's 10 years and there's 12 months in a year, and 10 times 12 equals 120. Okay, and then it's minus 1 over 0.04375 times $100, and then that gives us the future value. So the future value of the ordinary annuity is $15,737.70. So if you're using a scientific calculator, what you would do is you would type in 100, open parentheses, 1.004735, exponent 120 minus 1, close parentheses, divided by 0.004375 equals, and then you get your number, and you just cancel out these. So then you get 15,737.69, or you can round it up, 70. And if you have the BAA 2 Plus Financial Analyst Calculator like how I have, you would do second format to enter, second reset. And actually, if you have, don't let this confuse you, because if you have your calculator set at 2 decimal points, you don't really have to do this anyways, or this either. So then you start here, really, 120N, because it's the number of periods, 120 periods. Then when you do this, you don't have to press enter, because pressing N or the rate or present value, future value, or payment is already like pressing enter. So you do 120 N, then 0.4375 IY, which is for rate, 100 plus or minus to make it negative, because it's ordinary annuity, so it's paid out, right? Payment. So 100 minus payment is the payment due, and then compute, and then future value. So then here you're telling the calculator, I want to find out this. So then you press compute, and then following that is what you're trying to find, and you'll find that the answer is $15,737.70. And I'm actually going to try this on my calculator now. So I'll press 120N, then 0.4375 IY, 100, and then is the payment, and then compute future value, and there we go. So it works out great. All right. If you have the TI-84, which I'm sure none of you have, you put mode down, right, enter, apps, enter, 120, enter, 5.25 for the rate, enter 0, enter negative sign 100, enter 0, enter 12, enter highlight, and up, alpha, solve, $15,737.70. And the reason, this is the reason why none of you have the TI-84 calculator, because it's antiquated. We have better, more sophisticated calculators now. The future value of the ordinary annuity is $15,737.70. As an example, another one, find the future value of an annuity due of $15 monthly at $5.75 for 5 years. Here we have the rate, 0.0575, which is the decimal form of 5.75%, 12. Then we have just 12 months per year. So we have 0.00479166667, which is the period interest rate. So when we put $50 and in parentheses 1 plus the rate to 60 periods, because it's 12 months in a year times 5 years, and that gives us 60 periods, minus 1 over the rate without the 1 times the rate plus the with the 1 times $50, and that gives us $3,482.79. If you're using the scientific calculator, you'd put in 50 open parentheses 1 plus the rate, exponent 60 minus 1 close parentheses divided by the rate per period equals answer open parentheses 1 plus rate close parentheses equals $3,482, and basically this rounds up to 79 cents. If you have the BAA plus, you do second begin, second set, second quit, second format 2 enter, second reset, which again, if you have your calculator already set to 2 decimal places, you don't have to do this. 60 N for periods, 0.479166667, which is the period interest rate, IY, which is the period interest rate button. 50 plus or minus to make it minus for the payments. Second begin, second set, compute future value, $3,482.79. And I'm not going to go through this because I don't think anyone has a TI-84 calculator anymore. Learning outcomes for 14-2, find the sinking fund payment using a $1 sinking fund payment table. Find the present value of an ordinary annuity using a $1 ordinary annuity present value table. And find the sinking fund payment or the present value of an annuity using a formula or a calculator application. And by the way, I find this this image a little funny because the older generation of workers gets, from the last time I checked, they get about 80% for pension on average, and the millennial generation is going to get 50% or less. So for those of you who are going to be soon to enter the workforce, or even for those of you who are 40 years of age or younger for that matter, are probably going to fall into, we're probably going to witness the end of the Social Security system. There's just too many people, and people are living longer than the founders of Social Security had hoped that people would live. So it's a great thing. People are living much longer. Definitely, that's good. Yay for public health. But at the same time, Social Security is going to pay out and pay out fast. Step 1 for finding the sinking fund payment using a $1 sinking fund payment table. Please refer to page 508, otherwise you won't understand this part. Select the periods row corresponding to the number of interest rate periods, and you'll see it on the chart. Step 2, select the rate per period column corresponding to the period interest rate. Step 3, locate the value in the cell where the periods row intersects the rate per period column. And step 4, multiply the annuity payment by the value from step 3. Same thing. Yes, the same thing. Okay, here's an example of that. Using and I apologize for that. The redundancies that are present here in these PowerPoint presentations, I have no control over. I can't modify any part of this presentation because it comes straight from the publisher. So I apologize on their behalf for the typos and for all the way that some of these slides don't make a lot of sense. But here we are. Using table 14-2, find the annual sinking fund payment required to accumulate $140,000 in 12 years at a 6% annual interest rate. Table 14-2 on page 508 indicates that a 12 period at a 6% is equal to 0.0592770. Okay, so then we have the sinking fund 140,000 times the assigned number that we have to multiply that by, which gives us the 12 period at 6% value, is $8,298.78. So a sinking fund payment of $8,298.78 is required at the end of each year for 12 years at 6% to yield the desired $140,000. Again, use table 14-2 to find the annual sinking fund payment required to accumulate $100,000 in 10 years at 4% annual interest rate. Number of periods is 10. Find the table value where 10 periods at 4% intersect, and then if you look at the cross section, it's 0.0832909. If you don't know what I'm talking about, that means that you're not looking at page 508. So if you want to understand this section, you have to go to page 508. So you can find the table and then find where 10 periods, 4% interest rate intersect, okay? Then you multiply the desired future value by the table value, and that's all you do. The annual sinking fund payment required to accumulate $100,000 in 10 years is $8,329.09. And even if you do that, by the way, the value of the dollar is going to change over time. And if we look at the trend, looking at the histograms over the last couple of decades, it seems as though that is going to go down. So what $100,000 buys you today is not the same thing that $100,000 will buy you 10 years, 20 years, or 30 years from now. So we also have to be mindful of that you don't want to lock yourself down into an investment strategy to get a certain number that your heart desires, because in reality you want to try to really not take a hit at your quality of life, but at the same time you also want to develop a good enough cushion for you to have a good retirement. Find the present value of an ordinary annuity using a $1 ordinary annuity PV table. Step 1, use table 14-3 in your text to locate the given number of periods and the given rate per period. 510, please, page 510. Step 2, multiply the table value by the periodic annuity payment. So the PV of the annuity equals the periodic annuity payment times the table value. So as an example, and if you want to follow along, I'll keep saying it and I will never get tired of saying it. You have to go to page 510 and look at the table. Using table 14-3 to find the present value of an ordinary annuity in the payout phase with semi-annual payments of $3,000 for 7 years, a 6% annual interest rate, compounded semi-annually. So 7 years, 2 periods per year, this is where we get the semi-annually because it's 2 times per year. 2 times per year times 7 years equals 14 periods. 6% interest rate per year divided by 2 periods equals 3% interest per period, and it says compounding, so that's why we have to do this. So the PV of the annuity is 3,000 times 11.296, which is the factor that we get in the table, and that gives us 33,888. And of course, if you have the Texas Instruments financial analyst calculator, you don't have to look for this factor. By investing, so what does this mean? By investing $33,888 now at 6% interest, compounded semi-annually, you can receive an annuity payment of $3,000 twice a year for 7 years. Here's another example. Roberto Santos wants to know how much he will have to invest now to receive an annuity payment of $5,000 twice a year for 10 years. The money will be invested at 6% annually, compounded semi-annually. So the number of periods is 20. Twice a year, 10 years, 20 periods. The interest rate per period is 3%, right? Because we have semi-annual, compounding 6%. Semi-annual means 2 times per year. So this gets split in half, so it's 3% for both halves. That's where we get this number from. The table factor, if you refer to the table in your chapter, is 14.877. So 5,000 times 14.877 equals $74,385. So Roberto Santos must invest $74,385 now to receive a $5,000 annuity payment twice a year for 10 años. Find the sinking fund payment or present value of an annuity using a formula or calculator. So step 1, identify the period rate R as a decimal equivalent. Although you don't have to if you have the financial calculator. Number of periods N and FV of the annuity, then substitute the values into appropriate formula. So here are the formulas for the present value of an ordinary annuity and the payment of an ordinary annuity. So as an example, find the monthly contribution to reach 100,000 in 20 years with an annuity fund that earns 5.5 annual interest rate. So we have the rate, which equals 0.055 divided by 12 because it's per year. And then we get this tiny interest rate of 0.0045833333. And then N, we know that it's 240 because it's 20 years. And there are 12 months in a year, so you multiply that, and you get 1240. So the payment of the ordinary annuity equals 100,000, and it's going to be multiplied by, first, you work what's in the parentheses, the rate per period, which is 0.004, that number, and then it gets divided over 1 plus the rate, which is 1.004583333, and then as the exponent, the number of periods, 240 minus 1. So the payment required each month into the sinking fund is $229.56. If you have the scientific calculator, the way that you would put it in is 100,000 times the rate divided by open parentheses 1 plus rate, exponent 240 minus 1 close parentheses equals, payment equals, and then you get the 229. If you have the BA2 plus, again, you won't have to do this part because I don't know why, but the PowerPoint assumes that you never have your calculator set at 2 decimal points, which if it's a financial calculator, it should always be set at 2 points. You're never going to get 3 decimal points of a penny. So you put 240 N because that's the number of periods, and then the rate, which is IY, 100,000, which is the future value, and then you're going to put compute payment. And then you get negative 229.55 cents. And now I actually want to try this on my calculator. All right, let's see. So we have 240, which is N, 0.45833333, IY, which is the rate, 100,000, which is the future value, and then compute the payment. And there we go, it works out. And for the TI calculator, I'm just going to skip it. But essentially, the payment required each month into the sinking fund is $229.55. Here's another example. How much is needed in a fund that pays 5.5% to receive $700 a month for 20 years? And when you work that out, if you like, you can put the video on pause to work out the problem. You'll find that you'll need $101,760.85 to receive $700 each month for 20 years. And then this is basically just entering it into the calculator. And I'm going to try to plug it into my BAA2 plus. Alright, second. Alright, so then we do 240 N 0.45833333 Y. $700 payment, compute present value, and there you go, 101 $1,760.85. So remember, this is a nice chart that you can take along with you. Now we have payment in future value, sinking fund, and annuity. In the sinking fund, the payment is unknown. In an annuity, the payment is known. In a sinking fund, the future value is known, but in an annuity, the future value unknown. You can try to calculate it, but it is more certain in the sinking fund. And this concludes the video lecture, the long video lecture for Chapter 14 of the Business Mathematics text, as always, and I'm going to continue to say it. If you all have any questions, comments, or concerns about this chapter or any other chapters that you may have encountered, please let me know, and I'll be more than happy to assist you. If you need me to make you another video to elaborate on any one of the questions that are in the book, or if you want assistance with my math lab, we can always schedule some time and I can provide you that additional guidance. And as always, just shoot me an email, and like I've been doing recently for these video lectures, if you can send me an email identifying what this is right here, this image that I'm pointing to with my mouse, I will give you additional points for participation for watching this video. Thanks and have a great day.